Threshold. That's great. Okay, so we're doing a panel discussion on NEC stuff, realistically, but NEC updates, load controls, and emerging technologies. That'll be the general vibe of everything. So I guess I probably should introduce myself first since I'm talking. My name is Josh Brooks. I'm one of the service managers at Franklin, so I get to see everything that all the installers do everywhere with all the different products. It's super exciting. It's super fun. I'm a busy guy. Then we have Jay Sargami.
Hello, my name is Jay Zargami. I am a product manager here at Franklin. Can you hear me okay?
Just don't hold the black part.
Okay. Hello? Better? Okay. My name is Jay Zargami. I'm one of the product managers here at Franklin, and I focus mostly on EMS development and policy compliance, policy codes and standards. So I tend to dig into this stuff once in a while and help the team out whenever we run into any more difficult integration or compliance issues with the product.
And then we have Bill Brooks.
Hi there.
Don't put
Check.
the black part. The
Oh.
black part's the antenna.
Okay, there we go. So Bill Brooks, been doing this for a really long time, almost 4 decades. So we're going to talk about the code and fun stuff.
All right, so first thing we're going to start out with just a general commentary. So we've got the NEC 2020 or NEC 2023, which was recently adopted into the CEC, i.e. the California Electrical Code for their 2023 code cycle, and then the 2026 code language was just released this week. So there's a lot going on there. Can you give us the 30,000 foot 1 to 2 minute synopsis of things that are new and exciting there?
2026 code? Yeah, so 2026 code, which just got released this week. In fact, it's not even on my version that I have access to on NFPA. Is there's a lot of information now, a lot more information about power control systems. In the 2023 code, the language went to energy management systems and talked a lot more about energy management systems. But in the 2026 code cycle, they actually went back to the power control systems terminology, which I was involved in actually inventing that particular term. And it was more to piss people off than anything else, but it worked, and apparently it's stuck. And power control systems are really getting into the details of the safety side of load control, the safety side of source control. And so energy, it's still under the banner of energy management systems, but it is a specific, essentially sliver of that is more related to how we deal with actually controlling overcurrent and things like that. So there's a new standard, UL 3141. It's been on the street for about a year now. We're in the middle of revising it. So there's several task groups going on. And one of the aspects, I know this is a lot more than a couple sentences, has been providing additional detail for some of the new requirements in the 2026 code. So there was a provision passed in Article 702 about multimode inverters, and that is going to help us in some ways moving forward. And we're setting the rules for that, and those tests are being developed right now, and should be done in the next couple of weeks. Actually, they'll probably be done by November. And there's a lot going on. That's probably the most active area, and it does actually connect into the vehicle side of things. So vehicle to grid, vehicle to load, vehicle to home kind of things. The transfer equipment section for electric vehicles is Article 625. So that now talks about power control systems. And quite frankly, actually, power control systems, when we wrote the original proposals for the code, was really based upon Article 625.42, which was allowing us to use smaller conductors to run multiple EV chargers. And so we took that precedent that had been in the code for several code cycles, and we broadened it out to sources and to loads. And then it got incorporated into Article 750 of the code, which was energy management systems. And now in the 2026 code, the crazy thing is that energy management systems got moved to Chapter 1, which, if you know anything about the code, Chapter 1 is really kind of the heartland of the code. Something that used to be kind of a peripheral thing way back in Chapter 7 is now like right up front in the code. So that's pretty cool.
EMS, you mean, yeah?
Yeah.
Nice.
Sweet. So I guess in talking about load controls, we'll kind of shift it a little bit. So we know the code implications of load controls. Obviously, we could spend all day talking about it if we really wanted to. But I guess one of the defining questions is, I mean, you'll see a lot of products on the floor, a lot of things going on that. What do you think we should see? What do you want to start seeing from load control solutions, especially in the residential sector?
Well, this allows me to get on my soapbox.
Line 'em
You
up
know,
and watch
in the
'em go.
residential sector, obviously, that's what we're dealing with here primarily, and I know that Franklin's moving into other sectors eventually, but focusing on the residential sector, the four technologies that are really going to be linked together forever are solar, stationary storage, mobile storage, which we call electric vehicles, and then the fourth one is load control. And then the details of load control is really where it's at. So historically, load control has been, you know, you have relays and you turn stuff off and you turn stuff on, and it's kind of like I said, it was in Chapter 7. They let people play in their own sandbox. People have been doing commercial load control for decades. It's very mature technology used for primarily dealing with utility bills and keeping your utility costs down. That's what it's been about. Well, now it's a lot more with PCS and power control systems. It's getting into actually applying it so that we can actually reduce conductor sizes and we can reduce bus bar sizes and all that kind of stuff. And so that requires, again, this kind of higher level of safety involved in it. And so that's what we're looking for, is we're looking for power control system, load control systems that are then well integrated into the hardware that we're working with, so that it's seamless. It's not a bunch of kludgy things where people are running wires everywhere to do control of different loads here and there and everything. Some of it might include APIs that are connecting to thermostats and turning and EV chargers and controlling EV chargers. Because when you get right down to it, air conditioning and EV chargers are the two largest loads that are in any residence. An EV charger can use as much energy as an entire house. And so once you put that in perspective, you can get a lot. If you have actually some control over those really large loads, it can take the pressure off of having to worry about a bunch of little tiny loads all over the house.
That brings up a really interesting, I just thought of this. So with the load control functionality and technology sort of converging, do you anticipate there being any standard-based guidance for that, similar to NEM integrity mode functionality that's written into 3141? Do you see anything maybe written in, or will it stay under the EMS banner? Do you think that load controls might be specifically integrated to some, whether it's 3141 PCS, standard, or maybe somehow, does it need to be considered within a standard if it's going to be integrated as a subset of an EMS control then?
Well, the way UL is breaking it out in the 2023 code, 705.13, which used to be originally called power control systems, and then got changed to energy management systems in the 23 code cycle. talked about UL 916, and UL 916 was the standard, has been the standard that's been used for decades for load control equipment. That being said, because of kind of bifurcating the safety aspects versus the old school load control, they decided that that's no longer the standard that we would use. And in fact, nobody really had been using it up to that point. And that they established this new standard, UL 3141. And so all load control that is safety related is happening under power control systems, UL 3141. And interfacing with UL 1741 as well.
Right.
And so 1741, had a CRD that was basically an addendum that was developing a lot of these things, and that got peeled off and became 3141. So that's really where the action is, and that's where they're telling everybody to go when you're doing load control for the purpose of keeping loads within the range of ampacity of conductors and things like that. Whereas 916 was more about keeping the overall demand of a facility down to a certain level, which is a completely different issue.
Right. Okay, thank you.
All right, so in keeping with safety-minded things and misconstruing things and plugging things into your house all willy-nilly, talking about vehicle to load, specifically talking about hooking up generators, and how do we do that safely? So if we have a generator that's grounded, or say we have maybe a Cybertruck, sitting there in the parking lot with a 50 amp plug, it's grounded. We know that. Then we have a house. It's got a grounding electrode. Do those two grounds need to connect to each other?
Well, yeah. I mean, we're getting into the
open-ended question there.
Yeah. I mean, it's no different. As you pointed out, it's no different than any kind of a mobile generator. So all mobile generators are going to be either grounded internally or not, or have the option to unground them. Some generators are grounded and you cannot unground them. Others have the option of removing the link and things like that. And so if we're going to be using this to power our house, the typical way of doing it is, and you're going to be connecting directly into grounded circuits in your house, then you would normally want to lift the ground on the generator to do that. That being said, so because for instance, a standard plug-in generator, you have a Honda generator or whatever, and you're running your refrigerator off of it or whatever in your house, that you've unplugged it from the wall and you're plugging it into the generator, so its grounding is fine. As soon as you start taking that generator and then messing with the premises wiring of the house and introducing that to the house and then pulling your main breaker or whatever, that's a totally different ball game. And so now you've got a neutral to ground bond over here. And if you have a neutral to ground bond here, then you're just putting the equipment grounding conductor in the same path as the neutral wire. Which is it hazardous? It's just not correct. It's not customary. And there are potential issues that could arise, and if you have ground fault detection equipment, that could cause problems with that. There's all kinds of little things as to why, and the code does address the use of mobile generators to power premises wiring, and so they have the rules for that, and you have to follow that. The question is, does your Cybertruck or does your vehicle have those options available to you so that you can do it correctly? Or is it going through a piece of equipment that kind of solves all those problems for you so you don't have to mess with anything on your vehicle?
Yeah, I was actually going to, thank you for that. I was actually going to suggest something in the middle of that regarding isolation of that plug-in generator, whether it's a mobile or anything else that would be connected. The way that we do it at Franklin is using our certified generator input on the A-gate to manage the isolation part of things, and normally it would be a fixed generator that would be grounded to premises wiring normally, and that falls under one section of the code. And then more recently with our vehicle to load option, because that vehicle mounted generator is in fact grounded to the frame of the vehicle, it doesn't have that link that you can get in there. You know, the Ford Lightning user manual doesn't have instructions on getting in there and removing that ground link, right? And the code does have a provision in one of the articles that allows for that to be ungrounded. And so connecting that to equipment, what I've found in some conversations is has created a little bit of a chink in the armor of people's understanding of when a grounding electrode needs to be used, and the guidance that's within the code that allows isolated equipment, and the definition of equipment versus load. You know, that receptacle that is bonded to the vehicle frame ground itself, and then not changing the ground bond in the home or the premises wiring at all. So that's been a little bit of a contentious point in some conversations, and it's good to know that there is a path for compliance. But I still think that some AHJs may find some issue with, again, the word interpretation in big, bold letters when any code compliance sort of contentious issues come up. It's interpretation. So how do we get information, or how do we educate the public, or how do we get or suggest an interpretation that seems to be code compliant to AHJs that may see things differently, or maybe not consider certain parts of the code? How do we communicate best with the general public and AHJs on those issues?
Yeah, that's a good long question.
Yeah.
Yeah, I think you have to get down to the technical aspects of a solidly grounded service, and understand that, guess what, your utility transformer has a ground rod, and that ground rod is bonded to the neutral of the transformer.
Yep.
And then the neutral is again bonded at the
That's
service.
Yep.
And then if you're going to bond that neutral somewhere else, then things like equipment grounding conductors become less important. And the question is, if you have a grounded conductor and an ungrounded conductor, or a set of ungrounded conductors, like a split phase, then you really don't need or even want the equipment grounding conductor in that case. You have the power source, the vehicle in this case,
Yep.
has its bond, which you want,
Right.
and so it's safe, it's fine, and then it's just producing 3 wires, 2 hots and a neutral, to a location, and that location happens to be connected to something that is grounded. And then as long as our 2 hots are isolated from the utility transformer, we can safely power those loads. If there's a circuit that goes to those transformer leads, we got a big problem on our hands.
Totally different. Yeah.
Yeah. So our connection to the utility transformer should just be the grounded conductor, which, when the hot leads are removed, is simply just a ground wire, and it's just sitting there with no possibility of completing the circuit. And so there's nothing wrong with having that, which is the same thing as a Franklin system running on your house.
Anything, yeah.
When you open up the MID on the device, the microgrid interconnect device, that's exactly how you're doing it.
Right, but for when service providers run into issues of code compliance, and whether it's a plan reviewer or in the field an inspector, when having these discussions of should it be grounded or should it not be grounded, what are the best ways to provide any AHJ with a code section and article to make their case? So installers around the country may run into different issues from region to region. What's the best way to communicate, or to sort of like have a collaborative dialogue to find middle ground when there is disagreement?
Well, specifically about vehicles.
Yeah, the vehicle-mounted generator isolated from the area EPS.
Yeah, with vehicles, it really comes down to, I think, Article 625, and then having equipment that is listed and certified to operate in that, whether you're doing a DC feed off of the vehicle or an AC feed off the vehicle. And so, and if you go, if you get any more complicated than that, you're just going to blow people out of the water. And so that's really where, you know, it's up to these little tiny manufacturers like Ford and GM. To, you know, they're just under-resourced companies to provide good information about how they comply with the requirements of the National Electrical Code when their vehicle's being used in a situation where they're having to interface with wiring that's covered by the National Electrical Code.
Right. Okay.
You know, the vehicle, on the vehicle itself, none of that's National Electrical Code. You know, you can plug anything into a vehicle and it's still not the National Electrical Code. But as soon as you hook up a link to premises wiring, now we're in the National Electrical Code. So that link has to have whatever 625 and the certifications that go into that have to be there for that link to be done correctly, so it doesn't muck with anything and it doesn't create any weird things. And you know, they don't have this extra ground wire sitting in there that shouldn't be in there in the first place.
Yeah. Okay. Well, I won't get too deep into that. I'm resisting.
Yeah.
Thank you.
All right. Well, that kind of did set things up. So we started with V2L. That does kind of open things up for V2X. This is going to be my rant portion of it, having been that we've been actively searching for partners everywhere. We won't talk about it too much, but we have seen some large EV manufacturers start to dip their toes in the water of EVSE or V2X things, and what we've seen of those initial attempts seems to be some what I would consider a slow progress or measured progress, so to speak, if we're talking about measurements being not very fast. So with regards to the fact that we know what we can kind of expect from some of these larger manufacturers on the vehicle side, when we're talking about the actual, like you were talking about, the 625 interface point for a lot of these bidirectional EV chargers, especially dealing with the DC side, you know, one of the things that I'm seeing is, do we feel like everything's ready for those products to come to market and the code is ready for those products to come to market and we're just waiting on the manufacturers themselves to do it?
Yeah, I think the answer, I guess the short answer is kinda. We're the standards are definitely on the UL side of things for EVSE and all that kind of stuff. That's getting pretty good. I mean, I think we're and the technology side of that is pretty straightforward. I think the bigger hesitation right now is the automobile manufacturers, and always has been, by the way. I mean, again, this idea of bidirectional EVs has been around for at least 20 years. And so it's not a new idea. It's not like, oh, somebody came up with that. What do you think? Of course they've been talking about that. So, but the details of it, and, you know, the good news is that, you know, Tesla, GM, and Ford are all developing products that are in that space. And you know, of course, Nissan has been doing it in Japan for, you know, over a decade. You know, there's plenty of large companies that are doing it, and as a lot of these things are, they're going to happen in the proprietary stream of that vehicle and the company and all that initially before we get it too much broadened out from that. And that's some of the challenge in how do you interface with GM and Ford on stuff like this, because they're not that easy to work with, you know.
They don't return my calls for some reason.
Yeah.
So you can't just make a system level standard for like the vehicle use case for EVSE tied to the MID, whether it be a meter socket adapter or otherwise?
You can for sure. And so ultimately it comes back to that kind of end-to-end solution that the manufacturer is developing, like Tesla and others, where, okay,
closed systems.
yeah, now if we can take that system and now work with it to augment our system, which makes all kind of sense. And I don't see GM and Ford really getting into the stationary storage business. They could.
Not yet.
Not yet, but they could. I just, if they do, they're going to dabble with it, like a lot of big companies do. They just like put their toe in it and say, "Oh yeah, we're in it," and then next year they're out of it. So, but I think
Like Mercedes did several years ago.
it's that kind of stuff, and it's not their core business. And so
Yeah,
you have the
exactly,
higher ups going, "Why are we doing this?" And so it's going to be more about, okay, here's our solution for powering a house, and we know that if people want to power the house, they need to have access to all these other resources. Going back to my 4 things that'll be connected together forever, PV and stationary storage, my belief is that, your average consumer is not going to be able to afford an 80 kilowatt hour battery. That's just not going to happen. It's impractical. Even if energy storage came down by a factor of 10, it's maybe okay.
But in their car though.
Yeah, exactly. And from a cost point of view right now, but then a space point of view later, they're not going to generally do that. They don't have enough room to put it. But their vehicle that they're parking in their garage is a much different story. So
And also where they park it might matter for some age
exactly,
too.
it could. But the reality is that now that you have the mobile storage available to you, it opens up the whole process and makes it a lot more practical for the consumer. And in fact, in my opinion, it will actually enhance the EV market as much as it'll enhance the solar
Oh yeah,
market.
totally. Yeah, agreed.
Because people that would have maybe not even considered an EV before, they're going to go, well, I can buy this EV for cheaper than the mobile
Two
storage
birds with
would
one
cost.
stone.
Yeah, and get a car out of it, and that
Sure.
sounds like a reasonable thing to do instead of these things being all completely separate entities.
But then of course your car's got to be at home when the power goes out.
Well, that's why you have to have this. That's why you have to have stationary storage.
Exactly.
So you have a modest amount of stationary storage, okay, and PV that, let's take California example because of high electric rates. You do energy arbitrage with your stationary storage, and then when there's a major outage, earthquake, fire, whatever, you're going to be home anyway. You're going to plug your car in, you're going to be there, and now your big array that was normally doing energy arbitrage with with your loads in the grid is now doing it with the car.
Right. No, that makes sense. A modular system level approach. Yeah.
I don't know. It sounds like Franklin just needs to come up with their own EV at this rate.
That's next year's RE plus.
Exactly.
Thank you.
Cool. Well,
Awesome.
thanks everybody. We'll take a short break.